Hello. Hello.
Oh, by the way, do you know who invented the word hello?
Yeah, it was one of the presidents. Oh,
Alexander Graham Bell.
Hey, you stole that from me.
I did. Today, we're going to solve a, guess what, physics problem. Isaac, can you imagine a boat? A boat.
A bot?
Boat. A speedboat.
Okay.
Okay. What does a speedboat do? It accelerates. It has an engine. It accelerates.
I didn't know that.
Okay.
I thought it had legs and it just swam through the water.
The speedboat has a mass.
I didn't know that. I thought it was weightless.
1,000 kilograms. And the speedboat has a wind, like, pulling it against the velocity.
Oh my god, I thought Earth had no atmosphere.
So the speedboat is started from rest.
Oh my god, I thought it just spawned in from the factory and started moving.
And it's moved for 5 seconds. And 5 seconds it accomplished something 20 meters per second.
Okay.
All right, so we're going to find average power and instantaneous power at 5 seconds.
Instantaneous power is illegal. It is cursed. It is not correct.
So why the physics textbook has it?
It's an illegal physics textbook. The physics police already arrested the author.
I check all the physics textbook and they all have it. No. So you think you are better than all the people who wrote all the physics book?
No.
Okay. All right.
But I do think that not all physics textbook mention something as illegal as instantaneous power. But instantaneous power is essentially just the instantaneous change in kinetic energy over time.
At that moment?
Mm-hmm. Okay. So we have a man in a speedboat.
Oh yeah, I forgot to tell you.
Okay. So it's like leaving water, a wave behind it. Okay. So this is our speedboat, right?
Yes.
And the force of wind is 500 newtons, right?
Yeah.
Okay, and in 5 seconds, it manages to move, it manages to get up to 20 meters per second. What does that mean? That means that the acceleration, which is equal to the total change in velocity over time, is just 4 meters per second squared. So, what's the net force on our object according to Newton's second law? It's equal to the mass multiplied by the acceleration, which gives us 4,000 newtons. But we know that the force of drag is 500 newtons, which means that the force of the engine subtracted from the force of the drag is 4,000 newtons, which means that the force of the engine is 4,500 newtons. Alright, so what we're attempting to do is find the average power first, and then the instantaneous power, whatever that could mean. So average power is just work done divided by the time over which it was done. Now, the work...
Baby, can you write power? P?
Yeah. Now, the work done by the engine on the object is just the force multiplied by the distance traveled divided by the time. So the force is what? 4,500 newtons. That's probably not a good idea. Well, yeah, that is a good idea.
Oh, you have T. Yeah.
So our distance is just half. Our acceleration is 4 meters per second squared, and our time is 5. So we just have 2 multiplied by 25 is 50 meters. So we divide that by the time that it took, which is 5 seconds to get a whopping
We have calculator, baby.
45,000.
Sorry.
Which also means that the network is actually 40,000.
So 45,000 is what?
The engine, the engine power. Sorry.
Oh.
This is the net power.
Oh, okay.
Now, we have to find the instantaneous power.
Oh, this is net power?
Yeah.
No, 4.5 times 10 raised to 4.
That's the power done by, of the engine.
Yeah, 4.5 times 10 raised to 4. Yeah, so that's not correct. So,
It is. It's right here.
oh, 4.5 times 10 raised to 4. Yeah, that's right. Yeah. Yeah, that's correct. All right, baby. Okay, sorry. Was a disappointment?
Okay.
Oh, SI unit is missing. That's what I meant.
Okay. So now we can move on without this pedant disturbing us. Now let's find the instantaneous power.
At 5 seconds.
Whatever that means. So, power is commonly known as work over time. But work is the change in kinetic energy over time, which means instantaneous power should just be when we shrink the time to an unnaturally small interval, an infinitesimally small interval. So that's just dk dt. And what is that? Well, k is half mvt squared. So you take the derivative with respect to time. Use the chain rule. You get half m v of t squared. You use the chain rule, and you write 2 v of t multiplied by v prime of t. And what's that? This cancels out with this. You get m v of t, and v prime of t is just a of t. But m a is just f.
Okay, so 5 seconds.
But I think it would be best to keep it like this. So at 5 seconds, what is this? The mass is 1,000, our velocity is 20, and our acceleration is 4. It's instantaneous. In fact, I don't think... Oh yeah, this does change. I'm dumb. This gives you a whopping 80,000 instantaneous power, whatever that means.
Did I make mistake? I got 90,000. My math should be mistake than your math. I did not do calculus. I did do algebra.
You did FV. You did F of the engine. That's the instantaneous power of the engine.
Yeah, that's what I wanted to find.
I found the total net instantaneous.
Oh no, instantaneous power of engine.
Okay, the power of the instantaneous power of the engine doesn't really mean anything. But if you want to be a little freaking pedant, then you can just do m times a. That's 4,500 newtons for the force of the engine, and the velocity is of course 20, which gives you this, but that's practically meaningless, right? So this is the only thing that actually has some real world value.
So the 80,000 is, can you write it down? What is 80,000 and what is 90,000?
This is the net instantaneous power,
By,
which has more use as writing it as dk dt,
okay.
and well, this doesn't really have a use.
Oh, all right.
So average power is, well, the average value of the power being exerted over an interval. So it just expresses the average change in kinetic energy divided over time. So kind of like an acceleration, but slightly different. Meanwhile, this instantaneous power, which I feel like is still illegal, is basically just the instantaneous rate of change of kinetic energy.